Here we are given the function y equals 2 times e to the power of 4x plus e to the power of minus 3x. And we're asked to find dy dx when x is equal to minus a half. The function e to the power of x is the only basic function which has its own derivative. That is, dy dx is the same as y. Now, if the index is anything other than x, we could let it equal to u, and then dy dx is e to the power of u times the index differentiated, or du dx. So here, when we differentiate e to the power of 4x, we get e to the power of 4x, and differentiate the index, we get 4. So it's 4 times 2 times e to the power of 4x. Differentiating e to the minus 3x, we get e to the minus 3x, and differentiate the index, minus 3x, we get minus 3. So therefore, dy dx is 8 times e to the power of 4x minus 3 times e to the power of minus 3x. When x equals minus a half, we substitute minus a half for x, and we get 8 times e to the power of minus 2 minus 3 times e to the power of minus 1.5, which is minus 12.3624. In this question, we're given this pretty long expression, and we're asked to evaluate dy dx when x is equal to 1. Now, to do this type of question, we need to break it down into different sections. And as you can see, the first part of the expression is a product of two functions. So here we could use the UV rule, and the second part of the expression is an expression to the power of 2, so here we could use the chain rule. So applying the product rule, which is u times dv dx plus v times du dx, we could let u equals x plus 1 squared, and dv dx is the differential of log of 2x. So differentiate log of 2x, you get 1 over 2x, and then differentiate 2x, we get 2. Now v is the log of 2x, and u is x plus 1 squared, so differentiate u, we get 2 times x plus 1 times 1. Now, to differentiate the second half of the expression, we use the chain rule, which will be twice the bracketed term to the power of 1 times the individual terms differentiated, which will be 5 fours, 20, times x to the power of 4, minus 2 times minus 9, which will be minus 18 times x. Now, at x equals 1, anywhere we have x, we substitute for 1, which gives us the following expression. So if we simplify this, we get 2 squared plus the log of 2 times 4 plus 2 times minus 10, and if we simplify this further, we get minus 16 plus 2.772, which is minus 13.23. So if we were to plot this curve as shown in red, and if we were to draw the tangent at the point x equals 1, we would get the line shown in blue, which has a negative slope of minus 13.23. Here we are asked to find dy dx of the function y is equal to sine squared root 2x plus 1. Now we can rewrite sine squared of root 2x plus 1 as sine of root 2x plus 1 all to be squared, and root 2x plus 1 can also be written as 2x plus 1 to the power of a half. Now, to differentiate this expression, we use the chain rule. So dy dx will be twice the whole thing to the power of 1 times the bracketed term differentiated. So differentiate sine of root 2x plus 1, we get cos of root 2x plus 1. And now differentiate root 2x plus 1, which will be a half times 2x plus 1 to the power of minus a half, and differentiate the bracketed term, we get 2. The 2's will cancel, and rearranging, we get 2 times sine root 2x plus 1 cos root 2x plus 1 times 2x plus 1 to the power of minus a half. So we could rewrite this as follows, and just cleaning it up, we get 2 sine root 2x plus 1 times cos of root 2x plus 1 all over root 2x plus 1. Here we are given the expression y is equal to the log of x over the sine of 2x all to the power of 4, and we're asked to find dy dx when x is equal to pi over 4. First, we use the chain rule, so dy dx will be 4 times all of this expression to the power of 3, and then we need to differentiate what's inside the brackets, log of x over the sine of 2x. But this is of the form u over v, where u is the top, log of x, and v is the bottom, sine of 2x. So we could use the quotient rule, which is v times du dx, so it's the bottom, sine 2x, times the top differentiated. So differentiate log of x, we get 1 over x, minus v, which is the top, the log of x, times the bottom differentiated. Now when we differentiate sine of 2x, we get cos of 2x, and then we must differentiate the 2x, which gives us 2, and we divide the whole lot by v squared, or sine of 2x, all to be squared. Now we were asked to find the slope when x was pi over 4. So anywhere we have x, we could substitute pi over 4 as shown. Now this expression looks pretty complicated, but the cos of pi over 2 is 0 and the sine of pi over 2 is 1. So first, anywhere where we have cos of pi over 2, we could make this 0. So here we have cos 2 times pi over 4, which is cos of pi over 2. So this part of the expression will become 0. Now anywhere that we have sine of pi over 2, we could write 1. So here 2 times pi over 4 is pi over 2, so this becomes 1. 4 over pi is 1.27. Again, sine of 2 times pi over 4 is going to be 1, and the bottom here will be 1. So the expression simplifies to the following, which is just 4 times the log of pi over 4 all to be cubed times 0.79, which is 4 times this expression, which is minus 0.04. Here we are asked to differentiate with respect to x the implicit expression 2x to the power of 4 plus xy equal 6y cubed plus 8. The given function is an implicit function because it cannot be written in the form y is equal to fx. To differentiate this type of expression, first we differentiate term by term on both sides with respect to x. Now, as y is considered a function of x, if we differentiate any of the y terms to the power of n, it'll become n times y to the power of n minus 1 times dy dx. So, differentiating from left to right, when we differentiate 2 times x to the power of 4, we get 8 times x cubed as normal. But when we differentiate x times y, this is considered a uv type expression. So it'll be u, x, times y differentiated. And when we differentiate y with respect to x, we get 1, and we put dy dx beside it, plus v, which is the y term, times x differentiated. Differentiate x, we get 1. And on the right hand side, if we differentiate 6y cubed, we get 18 times y squared, and we write dy dx beside it. Differentiate 8, which is just a constant, we get 0. Now, simplifying the expression, we get 8x cubed plus x times dy dx plus y is equal to 18y squared dy dx. We now bring all terms with dy dx to the left and bring all other terms to the right. Next, we take out the dy dx term and then cross multiply to give dy dx is minus 8 times x cubed minus y divided by x minus 18 times y squared. And we can rearrange to give minus 8 times x cubed plus y all over x minus 18y squared. In this question, we are asked to use parametric differentiation to find dy dx if x is equal to t to the power of 3 plus t and y is equal to 2t squared minus 5t plus 7. Now, in this question, x and y are each expressed in terms of a third variable called the parameter. And this gives the parametric form of the equation, where x is equal to t to the power of 3 plus t and y is equal to 2t squared minus 5t plus 7. So we find the x dt and the y dt separately, and this will allow us to find dy dx. So differentiating with respect to x, first of all, we get the x dt is 3 times t squared plus 1. Now, differentiating y with respect to t, we get 4 times t minus 5. We now divide dy dt by dx dt. Now, dy dt is 4t minus 5, and dx dt is 3t squared plus 1. But dy dt over dx dt is the same as dy dt times dt dx. And the dt's will cancel, so this is just dy dx. So therefore dy dx is equal to 4t minus 5 over 3t squared plus 1.